Hello, today we are going to learn integration by parts. This section has two parts. The first part is integration by part approach for definite integration, and then integration by part approach for indefinite integration. First, move to the first part where we learn integration by parts for indefinite integration. Let me write the first part, part 1, which is indefinite integration. First of all, I will give you the method section, the method of this. Let u and v are two functions of x, then integration of u times v prime can be given as uv minus u prime v dx. So this is the formula for integration by parts. This is the case where we work on indefinite integration. All right, since it is indefinite integration, you don't have limits here. Okay, you don't have limits. If this were definite integration, you have limits like 5 to 6, 7 to 8, or something like that. All right, let's consider this example. You're gonna integrate x sine x. All right, so this is the given function that you're going to integrate. Just check whether you know any other formula to integrate this. Since we have learned integration, you might check whether there are any ready-made formula that you could use to solve this. The answer is no. No formulas to solve this. The way of solving this problem is using integration by parts. All right. So now you have to choose which is u, which is v. You have to choose v and v in this problem, which is hard, right? Which is hard. You don't know which one is u, which one is v prime. Because of that reason, I'm going to give you a small method section that explains how to choose u and v. This method work most of the times, but there are some cases this method does not work. So be cautious on that. This is the method of choosing u in integration by parts. Okay, this method has two steps. First step, the first step is you have to consider u is a function of power of a. U is a function of power of x. What are the functions of power of x? The functions you can think of functions like x. X is a power of function of x. The power is 1, or maybe x to the power 2. Here the power is 2. Functions like that. Or you could consider u to be an exponential function. An exponential function. Alright, that is e to the power x. Alright, so you could choose u as this, and in step number 2, if step number 1 does not work, let's say you couldn't find u as a function of power of x or an exponential function, then you have to move to step number 2. Okay, if step number 1 works, so you stop right there. You don't need to go to step number 2. If step number 1 does not work, so you have step number 2. In this case, u is a function that can be transformed to a function what I'm going to say is to a power-like function, to a power-like function of x. Or an exponential function after the differentiation. All right, if I would like to give you examples, the first example would be, just consider ln x. Let's consider ln x. So the derivative of ln x should be 1 over x, which is x to the power minus 1. Okay, so that means that ln x falls into the category it's a power-like function, right? This is a power-like function after the differentiation. After the differentiation, you will get a power-like function. All right, so then it's a power-like function because it is right. X to the power minus 1 is power-like function. So you could take ln as u. In the next case, just consider tan x, tan inverse x. The derivative of tan inverse x should be (1 over 1 plus x square). Alright, so you can say this is also a power-like function. This is also a power-like function, which is x to the power 2. And it has few other terms, but of course it's a power-like function. So you get a power-like function here after differentiation of that. So it satisfies step number 2. So both examples are satisfying step number 2. Alright. So this is the method. Let's work on one problem. So you have example number 1 right here. So let's solve that problem. Okay, let's solve that problem. Since you have this method, I think solving this problem is easy. Integration x sine x dx. Okay, so here you can take u as this x. Okay, it is just step number 1. It satisfies step number 1. Use a function of power of x. You don't need to come to step number 2. You don't need to come to step number 2. Why? Because step number 1 is already satisfied. All right, so that is u. U is x, and then if that is u, the remaining part of the function, the remaining part of the integrand is v prime. Okay, so it is v prime because the format should be u times v prime. That is u times v prime. All right, so you should have u times v prime here. That's what you have right here. All right, so you have u equals x and v prime equals sine x. Now you have v prime, but you have to find v. Now v should be integration of sine x dx. That is v. V prime is sine x, that means the derivative. Derivative is sine x, you have to get the function v. For that you just integrate that function. Integration of sine should be cosine, negative cosine x. Okay, now you know u and v. This is u and that is v. All right. Now everything is convenient. Now just you have to plug. You just have to plug those u and v's into this formula. All right. So let me to plug those into that formula. Integration u times v prime dx should be uv minus u prime v dx. Now you have to find u, which is already found, which is x, and then v minus cosine x, and then minus, then you have to find u prime. U prime should be the derivative of x, which is 1, so you put 1 here. Then v should be minus cosine x dx. Let me simplify this further. This is minus x cosine x. This minus with that minus, it is plus integration cosine x dx. All right. So now you have to integrate that part. This part is already integrated, so you don't need to worry about that. But still you have to integrate the second part of the problem. So this equals minus x cosine x. The integration of cosine is actually sine x. All right. Then finally you put the constant. Finally you put a constant because this is indefinite integration. All right. So that is the solution. This solution is for integration of x sine x. So that is the solution for the first example. All right. This constant is required. If you just lose that constant, then that will cause to reduce points. Make sure that you definitely you do not forget to put that constant. All right. Then go to example number 2. In example number 2, we're going to integrate ln x. Okay, we're going to integrate ln x. Now you have to find two functions. Okay, you have two functions in this integrand, but you see only one function, which is ln x. You see only one function, which is ln x. Right. So what do you do now? For that, you can just make a small arrangement like this. The arrangement is, I'm going to rewrite the given problem as ln x times 1. No problem with that, because I'm just multiplying ln x with 1. Now you have two functions. This is the first function, 1 is the second function. All right, so that's a small trick that I performed here. Now go to step number 1. Step number 1 says you have to find u as a function of power of x. You have to find a function of power of x. All right, so you don't have some function like that. There are two functions, none of them are like power of x. Now you have to go to step number 2. Step number 1 does not work, go to step number 2. U is a function that can be transformed to a power-like function. I have shown you this. ln x, if you get the derivative of ln x, it is x to the power minus 1. So that's a power-like function. This is a power-like function. So you can take your u to be ln x. Okay, so what I'm doing is I'm taking u to be ln x. So this is my u. If that is my u, this should be my v prime. Okay, so I write my u to be ln x and v prime to be 1. Okay, v prime is 1. Now you have to compute v. For that you have to integrate 1 with respect to t. Integration of 1 is x. V is x. And then you could use that formula. The formula says integration u times v prime dx is u times v minus u prime times v dx. Alright, so you write u times v, u is ln x and v is x, and then minus u prime should be 1 over x, and then v should be x dx. Let me simplify this. I write this to be x and x ln x minus, I can cancel this x to that x, then I write 1 dx. Alright, so then this is x ln x, and the integration of 1 is actually the power rule. You have to use the power rule. This is something like 1 is something like x to the power 0. Okay, so you can use the power rule. The power rule says dx, I'm sorry, the power rule says integration x to the power n dx should be x n plus 1 over n plus 1. That's the power rule. So I'm going to use the power rule right here. Minus, the power is 0, that means x 0 plus 1, 0 plus 1 plus a constant. So this is x ln x minus x plus 0 plus c. So this is the solution for the next problem, where here what we have done is we integrated ln x dx. Alright, so that is the solution for the next problem. So we have discussed two problems in this first part. In the first part we discussed indefinite integration. Now we are moving to the definite integration. Okay, part 2. definite integration. All right. First of all, I will give you the theory part of the definite integration. Let u and v are two functions of x, then integration from a to b u v prime dx equals uv from a to b, integration from a to b u prime v dx. All right, so the difference in this formula than the previous formula is this formula has limits. Okay, you can see it has limits. That is called definite integration. All right, it has limits, but it's essentially the same formula. This formula totally similar to the previous formula, but the only difference is it has limits. All right, let's move to the first example of this part. Actually, that is example number 3 of the section. Example number 3, you're going to integrate tan inverse x from 0 to 1. Tan inverse x from 0 to 1. All right. Here also you have to find u and v. Of course, you see only one function. Now you have to make two functions in the integrand. You have to make two functions here. You have to make two functions. For that, I can introduce one like I did before. I rewrite this as integration from 0 to 1 tan inverse x times 1 dx. Alright, so you take, now you have to find u. What is u, what is v? Okay, just go to the method. In the method, step number 1 is you have to find u as a function of power of x. That doesn't happen over there. It has tan inverse x and x. None of them are powers of x. Okay, so the method 1 does not work. Okay, go to method 2. Use a function that can be transformed to a power-like function of x or an exponential function after differentiation. Now you have tan inverse over there, tan inverse x. Once you differentiate that, it will give you a power-like function. Okay, so you have to use step number 2. Then this is your u and this is v prime. U equals tan inverse x and v prime equals 1. All right. Now you have to get v out of v prime. For that you are integrating 1 with respect to x. So v is just x. That is u. Give me a second until I go up. Okay. Now just let me use the formula. The formula goes like this: integration from 0 to 1, a to b. Original formula comes like a to b, right? In our case it is 0 to 1. That equals uv, and put the limits, minus u prime v from 0 to 1. Alright, so first write u times v. U is tan inverse x times v, which is x. The limits are from 0 to 1, minus u prime. You have to compute u prime out of this. U prime is the derivative of tan inverse x. If you can remember, the derivative of the tan inverse x should be 1 over 1 plus x square. Okay, so that's u prime. So you write u prime to be 1 over 1 plus x square, and then v should be x dx. All right. Now simplify this. First you have to substitute 1. If you substitute 1, you will get tan inverse 1 times 1 minus 0 minus x over 1 plus x square dx. All right. Tan inverse 1 is pi over 4, and then this is integration from, sorry, I forgot to put the limit, 0 to 1, 0 to 1. Integration from 0 to 1 of x over 1 plus x square dx. All right. Now you have to integrate this part. Okay, let me integrate that part separately. I take that to be a, and I integrate that one separately. All right. Consider integration of this part separately. Since we have learned substitution rule in this part, we are going to use substitution rule. In this sub problem, we are going to use the substitution rule. Okay, our substitution will be, let me use different letter for substitution, w. Our substitution will be 1 plus x square. All right, then get the derivative of w. W prime is 2x. Okay, now let me rewrite that as just d over dx. Sorry, dw over dx. The derivative of w, which is 2 times x. Right, then I solve that for x. Then I will get dw over 2x. I solve that for dx. Then I get dw over 2x, which is dx. All right. Now I'm going to do the substitution. I'm going to substitute things now. All right. So then I'm writing the original problem. Integration from 0 to 1, x over 1 plus x square dx. All right. Then since it's the substitution method, you have to change the limits. You have to get the new limits. All right. So let me get the new limits. I take some space here. I include some space here because I have to find the new limits. New limits are like this. If x equals 0, w equals 1 plus 0, which is 1. If x equals 1, w equals 1 plus 1, which is 2. Those are the new limits of w. So these are the limits of x. Now we have to change those limits to limits of w. Okay, so the new limits are w goes from 1 to 2, and you write x here. For the denominator, you could just write w times, for this part, you could write that part. Okay, let me mark them in different colors. For that part, you write this part. For this, you just write w. And then here you write dw over 2x. Then you can cancel that with that. And then this equals and then it's a simple integration. Now it's a simple integration, right? The integration of this one should be, that is 1 over w with respect to w, that is ln w. Integration of that one should be ln w. So this equals half ln w. The limits are from 1 to 2. First I apply the upper limit, which is ln 2 minus ln 1. Everybody knows ln 1 is 0. Okay, so this one should be, the integral of that one should be half times ln 2. Okay, take this to be equation number 1. So that is the solution for integration from 0 to 1, x 1 plus x square. Alright, so I'm going to plug that one into, let's say this is 1, and let's say that is 2. I'm going to plug 2 into 1. Substitute. Two into 1, that is a. Then you get integration. The original problem is 0 to 1. What we were integrating, it is tan inverse x. So integration 0 to 1, tan inverse x dx, which is pi over 4 minus this part, which is half ln 2. Alright, so this is the solution. This is the solution here. We don't have a constant. The reason why we don't have a constant, because this is definite integration. That's definite integration. Alright, so let's move to the next problem. Example number 4, which is the last example. In example number 4, we're going to integrate from 0 to pi over 2 theta square sine 2 theta d theta. Alright, this is what we're going to integrate. All right. So now we have two functions. It's clear. This is the first function, and that is the second function. All right. Now go back to the method section where this is explained. Step number 1, you have to find u as a function of x. Now the new variable is theta. Okay, the new variable is theta. Now you have to find u as a function of not x, function of theta, because your new variable is theta. Of course, you have that function right here. This is u. This is u, and that is v prime. Okay, your u should be theta square, and v prime should be sine 2 theta. All right, v prime is sine 2 theta. V should be integration of sine 2 theta d theta. All right, integration of sine 2 theta is minus cosine 2 theta over 2. That is your v, and this is your u. Now you know u and v. All right, now let's use the formula. The formula says integration from 0 to pi over 2. Here you have theta square sine 2 theta d theta. This is like u, that is like v prime. Now you write this to be u times v. All right, u times v means, sorry, no integration sign. You have to put square brackets. Here you have to put u times v, which is theta square times sine 2 theta. Then put the limits from 0 to pi over 2, and then negative. You have to put u prime. You can get u prime from this. U prime should be 2 theta. That is 2 theta times v minus cos 2 theta over 2 and d theta. You know this is u, that is v, this is u prime, wait a minute. I made a small mistake here. So this what I want to say is this should be v. Okay, what I have put down here v prime. What I put down was v prime, which was wrong. This should be v. V means that. Okay, let me make that correction. Let me take these out. And here what I am supposed to write is cos 2 theta over 2 and minus sign in front. This is v. That is v. Okay, now go forward. You have to simplify this part. First you have to apply the upper limit, which is pi over 2. Here pi over 2 is square, because that is theta square. And then here you have minus half. I'm going to put that minus half here in front. And then cos 2 times pi over 2. Okay, minus, then you have to apply 0, you get 0. All right, then in the next part, here 2, I can cancel this 2 with that 2. So what I get here is negative, negative, positive, integration theta cos 2 theta d theta. All right, now this is the remaining part I have. Okay, so you see this one, the problem here is there's no formula for this yellow part. There's no formula, and that is not integrated yet. So what do you do? So you have to use integration by parts for that problem. Okay, so this problem is a little bit complicated. So this is the given problem to you. In this given problem, you had theta square right here. You just use integration by parts, and then you simplified that problem into a problem like this. Here you have t to the power theta to the power 1, but still you have to use integration by parts formula one more time. Okay, let's use integration by part formula one more time. So let me take these lines out. Right, now let me denote this as A, and let me mark this as equation 1. I'm going to consider A. That is integration. I forgot to put the limits actually here. The limit is from 0 to pi over 2. Here also 0 to pi over 2. All right. Now again you have to find u and v. Like in the previous step, you can take theta as u and this as v prime. U equals theta and v prime equals cos 2 theta. Since v prime equals cos theta, v should be integration of cos 2 theta. Okay, so the integration of that one should be sine 2 theta over 2. Okay, then that is u, that is v. Now let me use the formula one more time. That is integration from 0 to pi over 2 theta cos 2 theta d theta. This is u, that is v prime, equals u times v, that is theta times v should be sine 2 theta over 2. The limits are from 0 to pi over 2 minus integration from 0 to pi over 2. Let me mark the functions. This is u, that is v. Okay, then here that should be u prime and v. Okay, u prime should be theta. U prime should be 1. U is theta, u prime is 1. So you write 1 times v, which is sine 2 theta over 2. Okay, let me simplify this further. So this equals, just plug the upper limit, pi over 2, then sine 2 times pi over 2. Okay, divided by 2, and then minus 0, and then here minus from 0 to pi over 2, and then let me take this half out. Then you write sine 2 theta d theta. Alright, so I'm going to simplify this further. Sine, here this is, you could cancel this 2 with that. Sine pi is 0. You know sine pi is 0, so the entire thing is 0 here. Yes, so this entire thing is 0, minus 0. Because this sine pi is 0. And then minus half, then integration of sine 2 theta should be minus cos 2 theta over 2. Now put the limits. Limits are from 0 to pi over 2. Alright, now here this equals this, here there's a half, another half, so I write it to be minus 1/4. And then this minus, with that minus I put plus, and then I write cos 2 multiplied by pi over 2 minus cos 0. Here 1/4, we cancel that with that. Cos pi is -1, cos 0 is +1. So this is negative, negative, -1, -1 is -2, over 4 is -1/2. Alright, so let me take that as equation number 2. Equation number 2 is actually integration 0 to pi over 2 theta cos 2 theta d theta. Okay, now we have already found part A, we already found that part, and then we have to plug it back. Okay, before that, let me simplify this part little bit. Okay, so let me get some space here. Simplification of this one should be here you have -1/2 pi over 4, sorry, pi over 2, so pi to the power 2 over 4, and then this can be cancelled with that. Cos pi is -1. Sorry, -1. Let me use blue color, -1. All right. And then simplification of this one is actually plus pi to the power 2 over 8. Let me write it at once. So for the entire part I write okay, let me go through 2 steps, otherwise you might be confused. That is the first step, and let me write this part plus 0 to pi over 2 theta cos 2 theta and in the next part I'm going to simplify this as pi square over 8 plus 0 to pi over 2 theta cos 2 theta d theta. Now I mark this as 1. This is a. Now it is convenient because I simplified this part to the end. I simplified that part to the end. So now it's convenient. So I can just plug equation number 2 into equation number 1. Equation 2 into equation number 1. All right. Substitute two into 1. Then I will get integration 0 to pi over 2 theta square sine 2 theta d theta equals pi square over 8 minus half. So that is the solution. All right. So what I have done is I have substituted this one over there. So that will give me the complete solution. All right. So this is the end of the section. We have discussed 4 examples. Two of the examples are in part 2, where we discuss definite integration, and 2 of the examples are in part 1, where we discuss indefinite integration. So this is the end of the section integration by parts. Thank you very much.